Now, what was our last class? The inverse, wasn't it?
Yeah.
Any questions on that? Yep. Okay, so what do you need to see? How many?
Transformations of functions.
Oh no, sorry, that was it. Transformations of functions, wasn't it? Yeah. So what questions do we have on that?
3J.
3J. Show me that now. 3J.
Yeah, that's not right. Okay, sure.
I'm going to do, yeah, transformation of functions, yeah. Let's do unit 2. I'll go previous to that, yeah. Which one there? Is that the same? It is, okay. Oh, okay. I'll just go through some. So firstly, 1K in the previous lesson. So if you look at the number in the front, you can see it's a half, which means the graph's, like its height gets divided by 2. So compress along y-axis by a factor of 2. Right? So far, so good. And then, when you have a minus, yes?
Is it negative sign?
That's what I'm going to do next. Now that we have the minus, what the minus means is you flip your graph upside down, which you say is reflected through the x-axis. And that's it. That's it. Okay, 3J now. So, before I start 3J, well, the start of 3J is to take out this 3/2 in front here. So, I need to put a 2 here. And the reason for the 2 is because minus 2 times 3/2 is minus 3. So these are kept the same. Now, which one do we start at? It's the minus 2, isn't it? Yeah. So your A goes from -1, -8, and then you move it to the right 2 units, So what's that now? 1 and minus 8, isn't it? And then you compress it along the x-axis 1.5 units. So you divide by 1.5. So that would be 2 over 3 minus 8. And then you resize in the y-axis by 1.5. So that would be 2 over 3, and then multiplying by this by 1.5 is minus 12. And then you slide it down the y-axis 2 units. So minus 14. I don't know, is that right, Hassan, at the back? Okay. Come on, hurry up, Faisal. Make it look like you're worried that you were late for maths class. You should be coming in going, oh, jeez, oh man. Too casual, too casual. Casual's not good. Okay, let's see. Okay. Got that? Yep. All right. No. Okay. Oh, it's just getting worse out there. Yesterday was nice, yeah. I think every morning now since maybe Monday last week it's been raining. Can't believe it. I feel sorry for those guys who are late for class and now are walking to school. Although I lie slightly, I don't really feel sorry for them. Okay, did you get that? Yep, all right. So this is the last worksheet of this chapter. Actually, and I'll have the derive program handy too. There's two pieces of vocabulary you need to know. First one is the modulus function, and I actually find in most places it's called the modulus function, except for in the States. So if anybody studied maths from an American curriculum, this word might be new. So if you don't know modulus function, it's also known as absolute. So what does it look like? So the modulus function is this one here. Now you've probably seen this before, the name might be new. So what it does is that if x is positive, then you do absolutely nothing and x is just x. There's no change. Whereas if x was negative, what you do is you flip the sign on your x, making it positive. So for example, absolute of 1 equals 1, absolute of 2 equals 2, etc. And then absolute of minus 1 equals 1, absolute of minus 2 equals 2, etc. Okay, so that's the definition. Write that down. What is the domain here? All real numbers. And the range?
Positive number.
All positive real numbers including 0. Is it 1 to 1?
Yes.
No. Many to 1? Yes. Is it onto? No, it's not onto, because what's onto? It makes all real numbers in the range. Okay. Let's have a look at some problems with this one. So the first one is I want to solve this equation. Whoops, 2x Hey, do you need to talk to my guys? Because I'm missing a few of them.
Quite a few.
Yes.
Ahmed,
Al-Baharn is not here. Neither is Brendan, no.
okay.
No.
Okay.
Do you want me to send them down to you if they come in?
No, it's okay, I'll check. Okay, thank you.
Okay, so plus 10 equals 6. Okay, so we want to solve this. Well, at the start it's just a bit of algebra, so you take the 10 out to the right. 6 minus 10 is minus 4, and then you divide by minus 2. So minus 4 divided by minus 2 is 2. So you get 2x plus 8 equals 2. Now, this is where you have two different methods to go ahead and solve this. Okay, so I'll show you both. So the first way you could solve this, which is definitely the easier way, is you could say, well, the only way the absolute of a number could be 2 is if what's inside is positive or negative 2. So you get 2x plus 8 equals plus or minus 2. So you get 2x equals minus 8 plus or minus 2. So you get x equals minus 4 plus or minus 1. So you get x equals minus 5 or minus 3. So that'd be one way to solve it. And the key here is by recognizing that the only way the absolute of something could be 2 is if the inside here is plus or minus 2. Yep. Oh, you know this. Minus 4 minus 1 is minus 5, and minus 4 plus 1 is minus 3. By the way, if I just made one tiny change and put a minus here, I can't solve it anymore. Why not? Yeah, wait. You're too slow. Go ahead, what are you saying? Yeah, and Abanu, what were you going to say?
I was actually going to ask for it.
Oh, you're going to ask me a question, right? You can't solve this if this is minus here because absolute must be positive, so it doesn't make any sense. Right, now what were you saying?
Yeah, then.
All right, okay. Question answered? All right. Now, a second way to solve this is by squaring both sides. And I'll explain in a moment why that works. So if you square both sides, you get 4x squared plus 32x plus 64 equals 4. So you get 4x squared plus 32x plus 60 equals 0. So you get x squared plus 8x plus 15 equals 0. So you get x equals minus 5 or minus 3 again. And I'll say why that works now in a moment once you write it down. So you have two ways you can solve this.
Should we give both ways?
No, no, no. Okay, why does squaring it work? Okay. So I claim that if I square this absolute here, that is the exact same thing as just x squared. I don't need the absolute anymore. Now if you square an absolute, the absolute goes. Why does that work? Well, you only really have two possibilities. Suppose x is a positive number. What's the absolute of a positive number? Positive. So there's no change. So I just have positive squared. Let me go down a bit here. Now suppose I have a negative number squared. What's the absolute of a negative? It's changed into positive. So I get positive squared as well. But now suppose I drop the absolute. Negative squared. Well, what happens when you square a negative? It's still positive, isn't it? And then, well, of course, what happens if you square a positive? It's still positive. So if you look here, with or without the absolute, it doesn't matter. You're always going to end up with a positive number. So you see what's happening here is squared makes something that's negative positive. Always. So the absolute is redundant. Do you know this word from English, redundant? Not necessary. So you don't need an absolute and a square. You just need the square. So you can square away absolutes. So if you want, I'll just... did you write this down? No? Okay. You don't need to write this down. This is just me explaining why it works. So I can put it up underneath as a result. Absolute squared is just the same as the x squared. You can come back at 10.
Sir, there was a huge traffic in Sedona.
I know, I had trouble getting here too.
I got here by taxi.
I know. You can come back at 10. It's the same as semester 1. Okay. Right, did you all write that down? Yep. Okay. Now, let's have a look at the graph of this. Well, if it's positive, what shape will it be? It's just going to be x, which makes it a straight line. And if it's negative, it'll go to be minus x, which is also a straight line. So we're kind of expecting two straight lines here. And that's what the graph looks like. So it just has a V shape to it. Nothing fancy there. Okay. But now, what happens if we want to draw something a little bit more complicated? So let's say, for example, we want to draw y equals minus 4. I can get rid of this. minus 4 x minus 3 plus 16. Okay. Any ideas how we could use something we did last week to help us draw this? Well, look, this here is like a transformation, isn't it? Like if you think about it, if I call this function here fx, yes, then this looks exactly like what you did last week, minus 4 f x minus 3 plus 16. So we could draw this by just transforming this original here. Okay, so let's start. What do we do first? 3 to the right, so I'll do a proper graph and derive, but 3 to the right we'll put it like here. And then what's next? It's 4 units vertical bigger, so that's get pulled up 4 units, so that'd be like this. And then the minus here flips it upside down, and then the plus 16 increases it by 16. So I don't know what it'll look like, but I'm expecting something that looks roughly like this. So let's use derive and see what we get. Can somebody read this back to me, please? So we have, oh wait, hang on. Okay, y equals minus 4 absolute x minus 3 plus 16. Okay. Now hang on. Zoom out. There we go. So I guess when I was roughly doing it, I didn't quite get the right scale, but it is what I expected. Upside down and more in the right here than, like, say, in the left or down below here. If you look at my graph, I expected the peak to be in the first corner here, which it is. Okay, so if you can draw this blue one, and then I'll show you a second way you can do it, which is the way they sometimes want in the exam, okay? So the first method is really just comparing it with what you did last week. So I don't know, do you need the graph up or do you need this up? Or neither? Will I just go on to show you the other way? Yep, okay. Yeah. Oh yeah. Yeah. They want you to draw it, and the way I'm going to show you now to draw it is much more accurate. Okay, so for example, let me just get rid of that F thing here. Let's just think back to drawing graphs in semester 1. What are the usual points we'd like to find to help us to draw the graph? Y-intercept and X-intercept. So firstly, how can I find the X-intercept? Let's do the easy one first, the Y-intercept. Yeah, so if you make x equal to 0, you get 0 minus 3, which is minus 3. Absolute of minus 3 is 3. 3 times minus 4 is minus 12. Plus the 16 is 4. So 0, 4 is our first point. And if you look at our graph, you can see that does roughly look like 0, 4 right there. Okay, now the trickier one is to find the x-intercepts. What do I do for that? So I'll call this point A. Okay, how do I find the x-intercepts? You make y equal to 0, don't you? Now, we've just seen how to solve this. 4 plus or minus 4. Whoops, there's a equals there. Plus or minus 4. So 3 plus 4 is 7, and then minus 3 minus 4 minus 1. And then what would the y values here be? What would the y values be? Well, there'd have to be 0, remember, because this is the X-intercept. So there you go, there's 2 more points. I'll call it B and C. So I have a couple of points found. I'll go back to this, don't worry. So the first one here, let me zoom in a bit. Whoops, wrong way. Okay, here. 0, 4. Now, this one here is probably the -1, 0, yep. And then this one here is going to be the 7, 0. So, is there any obvious last point I could find that would help me draw this graph nicely? What would that be? Which one?
Less current point.
Yeah, like this point up here would be good if I could find it. There's 2 ways I could find this. Any ideas on either way I could use to find this? Yeah, now unfortunately the absolute does not have a derivative, and we've not done the derivative of the absolute.
When the absolute is 0,
When what?
the absolute is 0.
Yes, that's one way. And then another way? Well, if you think about a quadratic, you know, a quadratic curve is symmetric. So if you picture a quadratic, the minimum will always be exactly in the middle of where the 2 X-intercepts are. So here is -1 and here is 7. So how wide is this? 8 units. So it should be 4 units from B, which would be 3. Yeah? And then to find the y, you would just put the 3 back into the formula at the start. But there is another way to think about it. So if I just pop it maybe here. Now, I want everybody to look closely. You have here a number multiplied by something which is always positive plus a number at the end. The form of this should look familiar. It should remind you of something we did in semester 1. Any ideas? Yeah? Any ideas? So I heard words, but one at a time. Yeah, that's it. This looks a lot like something that has a completed square. You have a number, something always positive, and a number. So when something is in completed square form, how do you find the min or the max? You make this part here equals 0, and this part here is equal to the y part. You remember? So here this would be D316. Now recall I just said a minute ago, where did I think the minimum would be? At 3. So it's not difficult to get. You just have to flip the sign here to make this 0, so that's 3, and then you just grab the number at the end, and that's 16. So we have the last one, 316. This is why I tell people question 2 is one you should do in the exam, because sometimes, in fact most of the time, they ask you to draw something like this and to label all the 4 points A, B, C, D on the graph. And that wasn't too difficult, so it should be good marks in the exam. Okay? Does anyone need the graph back? That's it there. Yeah. No, I'll say that again. They will ask you to draw and they will ask you to label the points. Oh no, it's always been modulus. Yeah.
The absolute.
The absolute, this one, yeah, yeah. Sometimes though, they might give you a graph and then they say, draw the graph using the following transformation. So they'll just give you like some rough sketch and then you're supposed to flip it or move it or do whatever.
You draw a rough sketch as well. It's not like one.
Yeah, that's it, yeah, yeah, yeah. No, they, for the absolute, like this one here, they'd want it on a nice graph paper and the points marked on it. So if you got that with the 4 points marked on it, whatever it is, like 4 out of 4 marks or whatever's going for it, okay? And then also, this is usually the second half of the question. Then the first half of the question would be, describe this transformation. So again, both things are not too difficult. You would say, translate to the right 3 units, expand on the y-axis by a factor of 4 units, reflect through the x-axis, and then translate up the y-axis 16 units. And then that together with the graph and the points could be like, I don't know, 6 out of 6 marks maybe. And yeah, it's the only other question that has easy marks would be the statistics question at the end. So that is one you're also going to do. Okay, next one now. Can I go next page? Yeah? Okay. So what about something like this now? Six, 3x plus 15 plus 23 less than or equal to. Right. Well, just like before, the inequality doesn't change anything to start with. So you take the 23 over. So what's that? Minus 18. And you got your 6 still there. And then you divide by 6. And since 6 is positive, it doesn't change this inequality. And you got minus 3. And again, there are 2 ways of going forward. And again, either method is fine for the exam. So, if I want this absolute to be less than or equal to minus 3, oh wait, hang on, something's wrong here. Something's very wrong. I think I missed a minus on my 6 here, so I'm going to add it in here. There should be a minus here, a minus here, so that makes that a positive there. I need to check those. So yeah, because if it was left as a negative, then what would be the problem? Well, it would be impossible, because you can't have a positive number smaller than a negative number. Or the only other thing that I can think of that maybe is wrong is maybe my inequality is the wrong way around. So something, either the sign is wrong or the inequality is wrong in that. I'm going to do it this way, as if there was a minus here in the front, okay? No, I'm just I'm changing the question, because if I kept it as a plus, it gives me something that's ridiculous here. Oh, and you're right, now it has to get flipped because of the minus, thank you. Okay, so there's 2 ways to go forward. So the first one, if I want this absolute to be greater than or equal to 3, then I need 3x plus 5 to be greater than or equal to 3. That's one way to do it. This here has to be more than 3.
It's 15.
What the heck? Sorry, 15. 3x plus 15 greater than or equal to 3. So you get here, well, take that over there, 3x greater than or equal to minus 12, so x greater than or equal to minus 4. But that's not finished here, because this would mean x, like for example, makes this 4, 5, or 6, but there's another way to make this greater than or equal to 3. If the inside here is less than minus 3. Like for example, if this was minus 4, what's the absolute of minus 4? 4, yeah? Which of course is bigger than 3. And if this was minus 5, it'd be 5, which again is bigger than 3. So you have two possibilities to think of. The first possibility is that this is more than or equal to 3. And the second possibility to think of is that this is smaller than or equal to minus 3. So then the second answer here would be 3x less than or equal to minus 18. So x less than or equal to minus 6. So if you put the two answers together, x must be more than or equal to minus 4 or less than or equal to minus 6. So that's minus infinity to minus 6 and then minus 4 to infinity. I think this is right. Let me draw the number line. So here is minus 6 and you want it to be less than minus 6. And then here is minus 4 and you want it to be more than minus 4. So, no, I think that's right.
Is it minus 6 and minus 4 included?
Yes, they are, thank you. My brackets weren't square enough. So what do you think the second method is for solving this? Yeah, you can square everything. Stop sliding. Okay, can you see the second way now? Yep, so second way is here you square both sides, so you get 9x squared twice the first 690x, is that right? 6 times 15 is 90, okay, and then 1 times 225 greater than or equal to 9. Can somebody square 15 and can somebody do 6 times 15 just to check that that's right? It is 225? Yeah. And it is 90 here, yeah? I can divide everything by 9, I think. Uh, 216 divided by 9 is 24, is it?
Yep.
Great. This quadratic has two answers. 6 and 4. Now, pluses, sorry. But on the graph here, you get minus 6, minus 4. And I draw my quadratic. Do I want above or below here? Above, so I want this piece, and then I want this piece. So you want from minus infinity to minus 6, and then from minus 4 all the way to the right to infinity. Which, no surprise, is the exact same answer. Now I want to have a look. No, you need to write that. Okay. Let me just go back here. So what was it? It was minus 6 and then plus 23. Okay, so let's just graph this here. Y equals minus 6 absolute, 3x plus 15 plus 23. Oops. Okay. So what I've done there is I've just graphed this piece, whoops, this piece here. I put this yellow piece on a graph. Now, let me put this piece on a graph. So if you think about it, I want this yellow piece to be less than this blue piece. So that means I want this red line to be less than this blue line. So when is the red line less than the blue line? Well, from minus 6 to the left and from minus 4 to the right. That's when the absolute function is less than this horizontal line here. Minus 6 to the left and minus 4 to the right, which of course is exactly this answer here. So as a graph, that's what you're doing. You're finding out when the absolute here is smaller than this horizontal line. So sometimes in the exam they might say something like, let me show you. First they might say draw this as part 1. And then part 2 will be solve this, and then part 3 will be describe or highlight on the graph where this solution is. So your answer would be to highlight from here down and from here down, and then color the x-axis in from here and then from there. Okay? Yes? Okay? Alright. Now another example. Okay. So now we have something like this. Now, I want to solve this. On the graph, what does that represent? What do you think? What would the graph of this be? Any ideas?
I think it's like the same like the previous one.
Yeah, so like this one here would be an absolute, wouldn't it?
Yeah.
And then this one here?
Absolute.
Absolute as well. So they could meet once, or they could meet twice, or they might not meet. For example, if one is like this and the other is like this, then they definitely don't meet. Or if one is like that and then the other one's like this, then they could meet once. Or maybe like here, they could meet twice. So you can have 0, 1 or 2 solutions. There are 2 ways to do this, but one of the ways I think might be a little bit too tricky for you or too complicated, because like before we considered this as positive and negative, and this one here could be positive or negative, but actually that makes 4 possibilities. Positive, 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 negative, negative, positive, negative, negative. So easiest way to do this would be to square everything. But before I square everything, I can cancel, What can I cancel? 7. Okay, now I square everything. So I get x squared minus 16x plus 64 equals 9x squared plus 24x plus 16. So you get 8x squared minus plus 36x. 64, 54, 48, yeah. Minus 48 equals 0. Okay, so that's equal to a quadratic, but maybe that's not too surprising, because if you remember at the start I said you could have 2 answers, 1 answer or no answers. So the fact that we got a quadratic at the end is not too surprising, because like a quadratic, it also can have 2, 1 or 0 answers. And I think I can divide everything here by 8, right? Yeah? No?
Yeah.
Yes?
But 6 is not divisible by 8.
I wonder if I made it. No, that's okay, isn't it? 6, 12, 24. Does this have solutions?
A fraction.
Fractions are okay. I'll tolerate fractions.
1.07.
That's not a fraction, that's a decimal. Give it to me as a fraction.
It's given as like minus 9 plus square root 1, like. No?
It's ugly, huh?
Yeah.
Ugly's bad. X squared minus 20, that's right, that's right. 6, 12, 24, 16, that's right. 8, 36. 64 minus 16, just double check that.
48.
You come back at 10, Ahmed. You can wait, hey, you can wait outside in the rain until 10, okay? Yes?
24 plus
40x.
Sorry, wait.
48.
Where's 40x?
24
24
plus 16.
plus 16? Oh, this one's wrong. Sorry. So this should be here 40. Okay, now they all divide by 8. But anyways, let's just put it into the calculator. What do we get here?
1 minus 6.
1 or minus 6. Alright, so there's the answers. 1 or minus 6. Okay. Yeah, let's just have a quick graph here of these two. So the first one was y equal to 7 absolute minus x plus 8, and then y equals 7 absolute minus 3x minus 4. Okay. So the first one, okay, there they both are. Zoom out. Oh, just making it worse. Okay. There we go. So what was our first answer? Minus 6 was one of our answers, yeah? And then, okay, so there's 1 there, and then there's minus 6 there. So they meet twice. Now, suppose I was to make a tiny change to this question. Suppose now, instead, I just said this.